My name is Matt Duff. I'm talking today on Git Simple, building a Git repository with Ruby. I work at GitHub as the service engineering manager. So the previous speaker, Kyle, was on the team, and we went out and visited customers, helped them get it set up with primarily GitHub Enterprise, and connect it to all the other things at work, help them teach them workflows and things of that nature. And I've been loving the job for about 2 years now. It's a fantastic place to work. Before that, I worked at a financial services company in Utah called MX, and they've both been fantastic and great users of Git. So the prior art for this talk is a few different places that I've just seen someone give similar presentations and wanted to do a variation of it. One of them is this person at GitHub. He gave a talk called Raw Git. Scott gave this, and he and I were at a conference one day, and he passingly mentioned it as we were manning a booth. And he said, I gave this talk one time, and I looked at it and thought, that's a cool way to approach this. And a lot of this talk is similar to what he gave back then. And then I attended, I think last year at Git Merge, she gave a similar talk to this, Emily. And then I also attended OSCON in Austin, Texas last year, and she gave this talk there, and I loved how she approached it, and I thought she was a fantastic teacher. So this is Dissecting Git's Guts, Git internals, and she focused mainly on the plumbing commands underneath the porcelain, and I thought that was how she approached it was really neat. I highly recommend going and watching that talk, and you can get all these access to these later for the links. And another one is by my colleague at GitHub, Matthew McCullough. This is a fantastic talk as well. This is on YouTube as well. It's Advanced Git, Graphs, Hashes, and Compression, oh my. And Matthew does a fantastic job in this of really explaining most things that are happening inside of it. It's much more broad than this one's going to be. And he does a deeper dive into some things as well and lays out the graph well. But this is also a really great place to go and to get a deeper dive in. And then probably the source material possibly for all of these previous talks is Pro-Git, the book by Scott Chacon, who is a GitHub founder. That one you can go and access free on the internet, and that's a fantastic resource as well. So my hope of giving this talk is that you will find Git to be much more approachable. Many of you probably could run circles around me in your Git knowledge. I am definitely assuming that is the case. But some of the potentially newer people for Git, it hopefully helps to pull back the curtain a little bit and demonstrate how simple of a system it really is and brilliant in its design, I believe. And then furthermore, we'll go through creating a few different Git objects in this talk. Try to recognize the pattern that we do with each one. So when we create a blob, when we create a commit, when we create a tree, there's a very specific pattern that we're doing with these simple Ruby command line commands. And so definitely recognize that and then go try to make a more complex one later. And the Ruby is very simple in it. It's really mostly strings and string interpolation of previous objects that you've created. So it's very a new user to Git or to programming could probably get a pretty good grasp of it just because of how simple the required tools are. And hopefully you build on this talk. So hopefully you hear this, you give it to people that you know, and try to help them see, you're not understanding what a commit is. Let's take 5 minutes and build one out so we can actually show you how it actually happens behind the scenes underneath the porcelain and the plumbing. And then hopefully give a better talk in the future. All right, we'll hop in now. So what is Git? Git, as you all know, is a content addressable file system. I assume that you all know. How that really is impactful is when you look into the Git directory, you can see all the files that Git is storing and all the content that it has in there to varying levels depending on the state of the repository. And the content is what is actually important. So if you have 2 files with the same content, there will be one version of it inside of this file system. And Git is distributed version control software. I'm assuming that I think we have people of varying levels in here, but Git, everyone has all of this history on all their local computers, and they can browse history and create history to their heart's desire. And with that, we'll move on to the main crux of the talk, which is the Git objects. So what are Git's objects? There's blobs, which are your files. And this can be the hello world string, or it can be something much larger. But it's mainly just a file that you write, and it's your source code files. This is the content, and a Git will make an object from that. You will also have trees, which are your directories for your repository. So Git will create representations of those for you as you go through and create your repository and add more and more complexity to it. And then there's also commits. So snapshots of those blobs and those trees at certain states during development. And that's, I would say, we go on site with customers a lot, usually very large organizations that are switching oftentimes from other version control systems. And that's something that is interesting to sit down and talk with people, where it's really just, this is a slice of your code at a specific time. Each commit is a snapshot in time. And having that understanding, I think, helps a lot for understanding Git. Let's jump now, and I'm going to create a repository, which will be the repository that we go and build through these Ruby commands. And I'm going to do it through just the normal Git porcelain commands. So for instance, right here, I'm in my project's GitHub Git Merge directory, and I make a new directory called Git Example. I cd into that repository. I initialize Git, so it initializes it, and then that's where most people kind of don't really care what's happening after that. They think that's good. And for my few years of using Git, that was probably where I was at too, where I knew that it was bringing me to the next step. But it's really important to say, ask yourself what's inside of that repository. So you can see that we have the .git hidden folder in there, and then we have all of these 4 or 5 other directories in here, files. And there's a whole bunch in there, but there's some that are more important than others. For instance, the Git objects folder is the primary place where Git is storing these things. So it created all of that just by typing in git init. But none of if you can see in the objects area, there's no content yet inside of Git. It's just the boilerplate repository, folders and files. So let's start creating some content. So still with the porcelain commands, you can I just do vim readme.md and type in hello world, save it and close it out, and you have your an example readme file. And that file was stored in Git. So now if we do that same command, we haven't done any committing or anything of that nature, but it's added it in there, and it has Git 3, the 3b18 is the hash of that file. So once we actually commit the file, that was just after we added it to the index. After we commit the file, then we just type in git commit -m created readme file. It goes through, it does create mode, it does all these things that most people just gloss over when they first get started. And then what is in the repository now? So now we have 3 files in there with a directory, as you can tell. I don't have a pointer, but if you can tell in the objects, you have the 21 folder, the 3b folder, and the 43 folder. It created those folders and then put the file inside of there, the content inside of there. So that's where those 3 files are. Those 3 files, from just creating that one folder in the commit, it created a snapshot of the file. It created the tree of the directory when it was at that point, and it also created the commit. So that's what we have right there. And there's a lot of things happening there, but not a lot of people dive into how that happens. So we're going to jump in now, and this is probably one of my, I don't know why I love this part of the movie so much, but let's do this thing. Let's go and start using some Ruby and jump in and make a directory just in IRB on the command line. So to start off, we just did make directory Git Simple Ruby and cd Git Simple Ruby to jump in, and then manually make the .git folder and subdirectories. So you jump into there and do make dir.git. So we're not doing git init, that's the main difference here. And we are creating the objects folder in there. And that is empty at this point. So we're going to go in and create the file. What's neat, so there's nothing in there right now, and we don't have all those other folders. We just have the objects folder, to be clear. So what's needed to make a GitHub file, or sorry, GitHub file, that was me replacing Git with GitHub instinctually. The content and the header information, and this is the signature of what that looks like for the header information. So that will be the blob is the type of content that we're creating. Instead of, to contrast that with a tree or a commit, we're adding the content length of that content, that first subpoint there. And then the header information is all of this, the length and the 0-byte character and the new line at the end. So with that in there, we're going to jump in and create the file content in IRB. And to do that, we just do blob content, and then I just add hello world. That's all I have. And I'm making the exact same one that I made in the other example. And that returns back hello world. It's a pretty simple string right now. We create the file header, and this is going to make it far easier for Git to tell you what the objects are after when you use some of those more plumbing commands, just to cat files and stuff like that in Git, or the porcelain commands. It'll use some of these values with the content of your actual file to tell you details about it. So it'll use the type, and then you'll have blob underscore content dot length is grabbing the length of that, and then you have the null byte character at the end. And then by their powers combined, the header and the content, when you add those two together, you get Captain Planet. Kyle's GIF game, I promise you before, is way stronger than mine, but this was one of my favorite childhood shows. So you get this string right here. So we save it as a variable called blob store, and we do blob header plus blob content with a new line, and that creates it. I just broke it apart just because it's simpler for me when I was going through to build it out this way. And you get blob, the 12, that null character, the hello world in the new line. And so we have the content, but we don't have a hash yet. So we know what the hash is going to be, the signature of that file is going to be. Now we need to actually make the hash. And the hash is very important for the content addressable file system, because that is the identifier for the actual content and what it will look like. So when we build out the combination of the header and the file content, that together becomes what the file actually is. And we make a fingerprint of it. So we're saying this is its fingerprint. It can't be anything but this because of the content of that file. We will require digest SHA in IRB. And we will run the command, and it gives us this long hexadecimal string of 3B18512, and that is the signature for hello world with our header. So now we can compress the file. So now Git will compress this file before it actually saves it. And what we're doing right now is the hash object plumbing command. So now it's time to compress that file. So we go in there and we require zlib, and we go in and do zlib blob store equals zlib deflate blob store, which is the one from previous, and it gives us this very nice string. And you don't have to worry about that though. You just have to worry about the zlib blob store. And this file now needs a directory. So we have the content, it's been compressed, and now we need to actually put it inside of Git to actually save it into Git. So we jump into IRB again, and we do directory, make directory, and we tell it to save it in the Git objects, and then we do a little string interpolation to pull out from that SHA, that 40 character symbol, the first 2 characters, to make the directory. So we're going to make the directory that it goes in first. So we drop that in, and it creates it there. And then we have that directory created. So now that the directory is created, then with Ruby again, we go in and make the actual file. So I just wrote a file open and then did git objects blob hash 02. And then that's telling it, you're making the path right now to where it's going to be. And then the second part of that is actually hashing the third to 40th character, however you want to count it, to pull out the last part except for the first two characters of that 40-character string and writing it. And then we're going to write the compressed zlib blob store in there to the Git directory. So now if we do a find dot, we have that 3B folder that we created, and then we also have the 1.8, the rest of that hash, as the actual content. So that README file now has representation inside of Git, just from relatively few Ruby commands that we did just in IRB in a couple minutes. What does the git log command now tell us? It tells us that we do not have a repository yet, certainly. So that's not going to work, and that makes sense because we just have a file. We don't have any commits or anything like that, and the logs are telling us our commits. So let's start building out those other aspects that we need to actually have a semi-functional Git repository from Ruby. So now we jump in and we make the tree. The tree is the folder representation at the time of the commit. So, and we create that directory. This is what values that needs. So it will have the object at the beginning, like before we had blob, now we have tree, the length of the content that we'll add, another null byte, then the mode, that's the file mode, and the name of the the name of the file, and then another byte, and then the SHA. And so now we can jump in and I can show you that in greater detail here. So we'll use the identifier for the README file, hello world, and there'll be an example in here of what that looks like when you write it out, so it'll be a little bit more clear. But we grab our file hash. This is the blob hash, so we have that from the previous one, and that is the representation of the README file in that directory, so we can make the directory. And then let's write out the tree content. We have the mode, we have the file name, the null byte, and we have blob hash and pack to compress it, so it's not that 40-character string. And then this is what it will look like if we catted that file after. Those values up above are used here. So you have the mode, the type, the string, and then the file name there, so you can check and see what objects are inside of Git. And then we're going to create the combination of the header for that tree and the content as well. So now we're doing tree content. This is what's inside of it. It has those characters in there. And then we make the header. So we also do tree content.length. Plus the null byte, plus the tree. I mix these are repeating a little bit just to demonstrate a little, but that's the tree header. Oh, and then I hit escape. Sorry, one sec. Then we have that, and then we combine the tree content and the tree header. So this is the actual content of what's going in all combined. So we have the tree store, which is what we're saving this as, the tree header, which is the first part of the string, and then that second part that's been that has those characters is the tree content. And then we make sure we have our required libraries, just like in the previous step before we start compressing and adding it. So we have tree hash equals digest SHA-1 hex digest tree store from the previous slide, and it gives us back that SHA. So the SHA is what that file will actually look like in the Git folders. And now we can create the directory for the object. So this is that pattern that I was referencing before. There's a very similar pattern for every object. So now we create the directory. We again grab the first two characters of the SHA, and we then make sure we add the file after in the newly created directory. So we do file open and then save it just like before with the last characters being the file name. And still doesn't work when we run git log without a commit. So if we have to go and now create the commit, because we have the tree, we have the file, but we do not presently have a working Git repository in the way that you'd anticipate. So we can now create the commit content, and this is what it looks like when you create the content with some new lines in there. So we have the commit content variable up there, and we make a reference to the tree so that the commit knows where it's coming from. We have the author, that's myself. We have the committer, which is myself. We have the created README file, which is the message, and then we end the string, and that spits back all of this string on the bottom 2 lines. So we're building out now that into the system. So now that's simply the content. Now the header is the commit, the object type, which is the commit part in the variable. And then we do the length again as well, and then a byte there at the end, a null byte. So then we have combine them for the complete content, the content and the header, and we get this long string. So that's what the SHA-1 is going to be created from. And we create the new folder for the commit. So we dive in, and we make the directory. We do the first 2 characters for the folder, and we add the file to the new directory, like before. And what does our directory look like now? It has all these files in there. So there's 3 files in there. So we created the blob, we created the tree, and now we have the commit all inside of the repository. And so this is still a wildly simple, there's no refs folder in here yet. It's a wildly simple Git repository, which will not work if you run git log because there are no references. So at this point too, this is good to point out. At this point, the one that I created before with the porcelain commands, and that did everything for us, these are the same values as the other one, except for the commit file because that has timestamps in it. So other than that, though, that's the same tree and file hash as before because it's the same content, and that's how that system works. So now if we go and look, git log does still not work. So it'll still say it's not a directory. So we're missing our references. So let's add that to the folder. So we jump in and we do make dir-p git refs heads to make sure that it makes refs and heads. And then we add the master branch reference with your commit SHA. So we need a reference to Git that this is actually a branch as well, and we're going to make it just automatically the master branch. And so we dive in here and do echo the commit message, and then add that to git refs heads master. And then we let head know to go look into master to see what the current one is. So we echo refs heads master to git head, and then it's hooked up and it knows where to go. And does it work now? It does. Git log works. So now when you run the git log command, it's aware of the content that's in there. And you can also run many normal Git commands now with just this simple Ruby created repository. So you can see up here at the top, I ran git cat file -p, and that decompresses that file, the readme.md file, and spits back hello world, which is the content there. The git cat file -t tells us the type of each of these 3 objects in the database, the blob, the tree, and the commit. So these commands are working fine. My little bash profile script is recognizing the master branch now because it's in that file, and things are working just fine. Now, there's obviously far more complexity inside of Git on top of this. This was a fundamentals of how Git objects work, but the repository is functional. So that, what can you do with that knowledge? So you can test this out for yourself. You can make some nested trees. You can get a little bit more complex. You can see, how do you write those different strings out when you add content on top of content. and you can try writing out more of the functionality in Ruby. For instance, it wouldn't be a stretch to find out what the current branch is by writing your own Ruby command. Knowing now where those things are stored, that shouldn't be overly complex. And letting Git know you changed branches is another thing that you could write out in Ruby, or your scripting language of choice. Doesn't have to be Ruby by any stretch. And you could give a talk demonstrating this to others with Git knowledge. So that is the bulk of the content. I wanted to give some time for questions. And I'm going to post these notes with also the step-by-steps written out, generalized, at mattcan'tstop/Git Simple. I'll post this after and have a little template for a new person to go through and test out building out their own commands, which I would have found very helpful in my earlier days. So with that, I can open it up to some questions. I figured it wouldn't be terrible if it ended a little early today because it's the last one of the day. So what questions do people have? All right. Yeah, that works. Oh yeah, go ahead. There's someone over here. Uh-oh. I think we may need a different mic. Oh. So, yeah, if you could repeat that. Sorry. Chef? Okay, yep. Yeah.
Test.
Yeah, I would assume just for everyone and for the video in case they couldn't hear, they're using Chef, and he was wondering if you could use some, if you could script out some of this instead of using the Ruby porcelain commands. I would probably use the Ruby porcelain commands just to stay safe, because there's other things that could be happening, and this was showing it at a very simplistic measure. But if you get, diving deep into the trenches, you could miss some things, scripting out your own. I think it would be a fantastic thing to try, and to just see how it works. And you'd certainly learn a ton about Git and how it functions in Ruby as well, if you did that exercise. But I certainly do not do anything like this when I'm interacting with my team, in repositories. This is more of a, dive into it for fun, especially for, maybe people from our experience teaching people Git, like people who are in the new to intermediate range. They understand the porcelain commands pretty well, and they get that concept, but they don't really know how anything is happening underneath. I think it's a fun exercise to dive in there and to just create something simple like this, just so they really internalize, oh, it's 3 or 4 library calls, to make these files. But yeah, I think it'd be a very fun thing to try, and if you do, let me know. I'd love to see it. Any other questions? All right. Thank you, everyone, for coming up. Brandon? Yeah.